Swayam Prabha. Digital India. Educated India.
So welcome back. So in the last lecture we just started one problem which is more towards practical sense, and some practical related issues were getting solved in the last problem. So there actually we have analyzed borrow area A, and we have seen that how much was the total cost coming if you choose borrow area A. Now similarly, if we choose borrow area B, so basically for borrow area B, your E natural is given as 0.68. So volume of soil needed to contain that remains same, 32,075 cubic meter of solids. Okay, that will be coming as 32,075 multiplied by 1 plus 0.68, which comes around 53,886 cubic meter. So this much volume needs to be transported from borrow area B if you choose borrow area B. Okay, so number of truck trips required to be made is equal to, by using or by considering the allowance of 10% increase, that 53,886 into 1.1 divided by 10. So that comes around 5928 number of trips. Okay, to transport, to excavate, to transport, to transport the soil from borrow area B. So this much or this many number of trips, truck trips you need to transport the soil. Now amount of water present in 53,886 cubic meter of soil is equal to what? So natural water content multiplied by the weight of soil solids. So what is the natural water content at borrow area B? That is given in the problem, 14% multiplied by what is the weight of soil solids, that already has been calculated in the last lecture, 8.33 into 10 to the power 5, which comes around 1,16,620 kilonewton. So additional amount of water needed is equal to, this much of water is really required for constructing the embankment, 1,67,000, and this much of water is present in the soil if you choose borrow area B. So this much of water you need to transport by trucks. So 50,380 kilonewton. Okay, so number of truck trips required to transport water is equal to 50380 divided by 10 into 9.8, which comes around 514. So total cost of using borrow area B, which comes around 5928 number of trips to transport the soil, excavation, transportation and compaction, into 500, that is the rate, plus 514, that is the number of trips required to transport the water, into rate is 150, which will come around rupees 30 lakhs 41,100. Okay. So therefore, which one is economical? So if you compare the cost, so the borrow area A is more economical. So therefore, using borrow area A is more economical. Okay. So we'll continue with the next topic or the next chapter, that is on permeability of soil. Well, so now we are going to start the new topic in soil mechanics, that is permeability in soil. Now what do you mean by permeability? Basically, as you have seen from your earlier discussion, that every soil deposit will be having some pore space or the void space, right? And those void spaces or the pore spaces are interconnected. So you cannot have some discrete kind of void space. So some void space is here and that is not connected to other void spaces. So that will make some channel kind of thing. Okay. And now if you allow or if you put some water on top of that soil deposit, now it will, that water will try to percolate through the void space and it will go out from the soil matrix. Now this phenomena or this concept is known as permeability. Now from your earlier say knowledge or from your earlier experience, you can appreciate that in case of say granular soil or the sandy soil, if you put water on top of the sandy soil, now what will happen? The water will immediately drain out. But if you do the same thing for some clayey deposit, you put the water on top of some clayey deposit, you will see that the water will be retained for a long time and slowly it will percolate. So these two, I mean both the things are giving you the permeability concept, but the depending on the different types of soil, different types of packing, different types of gradation, you are getting different types of flow, I mean property or the flowability in the soil matrix, right? So these are the things or these are the issues we are now going to discuss, and these issues are very, very important. Now suppose you are considering, you are constructing one dam, right, and you are constructing one reservoir just behind the dam, and if your reservoir bed is allowing the water to seep through or to percolate through the soil matrix, then you cannot retain the water in the reservoir. So your whole purpose is gone. So you need to know this permeability concept in a very well I mean designed manner, so that you can design those kind of water retained structure, or where you want to have some issues where the draining of water is happening. So that kind of issues you can tackle. Now what is permeability? So soils are permeable, as I told